Hi guys. So in this video we're going to continue looking at sets of things, in particular sets of numbers, and we're going to see how we can look at describing sets of infinite amounts of numbers. Okay, so let's start off by thinking of the most natural set of infinite numbers you can think of, and this is usually the set of numbers that you start off learning when you're a little child. Okay, it's just the counting numbers. So you count how many things you have in your hand. This is called the set of natural numbers. Okay, so natural numbers. And they're just basically the numbers 1, 2, 3, 4, 5, 6, 7, and so on, all the way up to, well, infinity. There's infinitely many of them. Okay. Now, if you're trying to write down all of these numbers and include them in a set, that's really hard to do because there are so many of them. There are infinitely many of them, right? You can't just keep writing forever. So we've invented a symbol that we use to describe this set of numbers, okay? And that is this sort of funny looking N. You'll see it sort of written like that. It's sort of just like a bold N. I don't care if you write it as this weird bold N or just a normal N, we'll know what you're talking about. But that symbol here, that is just the set of natural numbers, the set of positive whole numbers. Okay, you don't have to go and write, open bracket here, 1, 2, 3, 4, and just keep writing more and more numbers. Okay, because you can't. There's infinitely many of them. So you just use this symbol N. Okay, that means you're talking about this set of natural numbers, the set of positive whole numbers. What if you wanted to talk about negative whole numbers as well, or as well as the number 0? What sort of numbers are these? Well, we call these the integers. Okay, these are just the set of whole numbers. They can be positive or negative or 0. Okay, so things like, well, you could start off down at negative infinity, start counting by, ones, whole numbers. So you can just eventually get to negative 2. What's going on? Negative 2, negative 1, 0, 1, 2, so on and so on and so on in either direction. Okay, these are called the integers. We symbolize them with the letter Z. Don't ask me why we use the letter Z. I think it's got something to do with some German word for numbers or something like that. I can't remember. It's just the symbol that we use to signify this set of whole numbers, positive, negative, or 0. All right, we've also got another kind of number that we use in everyday life, and these are fractions. So you can have, 1 over 2, 1 over 3, 1 over 4, 1 over 5, and you could just keep going, adding 1 to the denominator. So you can see there's going to be infinitely many fractions as well. Okay, and we're not even talking about changing the numerator. So how do we describe this set of fractions? Well, we give them a name. They're called the rational numbers. Okay, they're called rational numbers because fractions are a ratio of whole numbers. Okay, they could be positive or negative. So rational numbers are things like where you've got some number p divided by some number q as a fraction. Here, p and q have to be whole numbers. Okay, you can always express a fraction with whole number numerator and denominator. So we say p and q are part of the set of integers. But we also have to signify the fact that you're not allowed to divide by 0. So we also have to include this statement here saying that q is not allowed to be equal to 0. Okay, so this statement here captures us trying to describe all of the fractions, basically. Okay, now the symbol that we use, just like we use n for natural numbers, z for integers, we use q, funny looking q, to signify all of the fractions, all of the rational numbers. Why do we use the symbol q? Well, q stands for quotient, and the quotient is what you get when you divide two things. Okay. Now, there are some numbers that we can't write as a fraction of two whole numbers. Okay, you may know some of them. The most famous one is probably pi. Okay, so pi, other numbers like surds, so square root of 2, square root of 3, and so on, these cannot be expressed as a ratio of two whole numbers. Okay, so they're not rational. We call them irrational numbers. And they make up the rest of the numbers. Okay, in fact, there's infinitely, actually, the number of real, so we call them the real numbers. Okay, this is just all the possible numbers you can think of, and they include anything. Okay, they include natural numbers, integers, rational numbers, and irrational numbers. Okay, so that's just any number you can think of. Right? We use the symbol R to signify the real numbers. Okay, so that includes all of this stuff, as well as things like pi, square root of 2, Euler's constant E, things like that. Okay, just any number you can think of. Okay, we're not talking here about complex numbers. Complex numbers you can leave for the people who do specialist. In the video description, I'll link to a cool video by Numberphile that describes, all these types of numbers and how they're all related to each other. So check the video description for that. So there we go. That's a way to describe infinite sets of numbers. We just use a symbol, and then your brain can fill in the rest. If you use the symbol n, your brain would know you're talking about all the positive whole numbers. Okay, you don't have to write them all down. You just know that that's what you're talking about. What if we only wanted to include a certain proportion of real numbers? Okay, so let's say you might want to try and include all real numbers between 0 and 1. Okay, all real numbers between 0 and 1. Okay, how would you try and write that out using some kind of set notation? And let's say we're not including 0 and 1 here. Let's say we're being exclusive. Okay, so what do we do here? Do we use a symbol? How do we do this? Well, turns out it's kind of like a cheat way to write the set of all of these numbers. You just say the set of all numbers x such that, so these two dots mean such that, or with the restriction that x lies between 0 and 1. There you go. That's how you describe that particular set of numbers. It's kind of a cheat way because you're just using maths notation to rewrite this sentence that you've made for yourself. But that's it. Okay, so we read it as the set of all numbers such that those numbers are between 0 and 1, excluding 0 and 1. Okay, they're strictly sort of less than or greater than. Okay, we're not including 0 and 1 there. If you did want to include 0 and 1, so same thing, all numbers between 0 and 1, but we're being inclusive now, you just replace those less than symbols with less than or equal to symbols. So we just say all the set of numbers x such that x is greater than or equal to 0, but less than or equal to 1. Okay, that's it. That's all you do. Okay, so you don't have to sort of write them all out. In fact, there's infinitely many numbers between 0 and 1, because you could have, say, 0.1, 0.01, 0.001, 0.0001, and just keep going adding zeros, and they're all still between 0 and 1, but there's infinitely many of them. Okay, so you can't list them all out just by writing. You have to sort of describe them with this rule, I guess you could call it. All right, what about other sets of numbers? So we could have all numbers greater than 3. So what if you wanted to include all the numbers greater than 3 in a set? Okay, how would you do that? Well, kind of exactly the same way we did the last two. You just write this again using maths language. So you say, this set contains all numbers x such that x is greater than 3. Done. Okay, that is that set of numbers. That's how you describe it. That's how you write it down. So you're kind of cheating a little bit. You're just saying, yep, x, this set contains all numbers x such that x is greater than 3. And you leave it at that. All right, what about something weird like all even numbers? How would you write down using some kind of rule the set of all even numbers. Okay, well, you can't really write it as sort of like x greater than something because they're not greater than anything or less than anything. But think about what an even number is. Okay, you know that even numbers can be evenly divided by 2. Okay, they're divisible by 2, or 2 is a factor. Or in other words, every even number can be written as 2 times some whole number, right? Okay, the number 30 is 2 times 15. The number -8 is 2 times -4. Even 0 is 2 times 0, okay? So all even numbers can be written in the form 2 times some whole number n. So we have to specify that n is a whole number. So the way that we do that, you just write 2n such that n is a whole number, or n is an integer. And we know how to write whether or not a number is an integer. You say that n is part of the set of integers. Okay, so that's how we write all even numbers as a set, okay, in set notation. What about odd numbers? Well, if you think about it, an odd number is just some kind of even number plus 1. Yeah? And we know how to describe even numbers. That's what we just did. Okay, so all we got to do there is write that again, except instead of 2n, an odd number would just be 2n, whatever even number you have, plus 1 more. That would give you an odd number. So it's 2n plus 1, where n can be any integer. Okay? There you go. That's all odd numbers. So think about that one for a little bit. See if it makes sense to you. Okay? Just read it. Really think about it. Maybe try replace 2n plus 1. Replace the n with, some kind of integer. Just make sure that it works. All right, what about if you don't want all the odd numbers, you just want positive odd numbers? Positive. Good thing this isn't an English video. Positive odd numbers. Okay, so this one's a little bit different. Okay, look at the last one. Okay, we're talking about all odd numbers. So if you replace the n with, say, -4, you'll get 2 times -4, which is -8, plus 1 is -7. So obviously -4 is not going to work in this set, okay? So it'd still be 2n plus 1. That's still an odd number, but you need to restrict your values of n to be a very specific group of numbers, okay? And in fact, so long as n is 0, or 1, or 2, or 3, or so on and so on, then that will give you a positive odd number. Okay, if n is 0, you get 0 plus 1, which is 1. If n is a 1, you get 2 plus 1, which is 3. If n is a 2, you get 4 plus 1, which is 5. Okay, so that'll give you all the positive odd numbers. If you stick n is -1 into here, you get -2 plus 1 is -1, so it doesn't work. Okay, so anyway, that's how we describe infinite sets of numbers. Okay, some of them you sort of cheat a little bit and you just like rewrite your sentence in terms of greater than and less than. This is very specific notation here when we're trying to describe numbers that lie between two other numbers. This is actually called an interval, and that's what we'll discuss in the next video, okay? Or you try and describe your set using some kind of rule. So you say that if you want all the even numbers, even numbers are 2 times some other whole number. And that's what you write, 2 times some number where this number n is a whole number of some kind. That will give you every possible even number. Okay, so we'll stop there. Go back and watch the video, review it, make sure you understand how we got all of these set notation rules. All right, and I'll see you in the next video.